Okay, so we're going to talk about mass spectrometry. So the first step in all of this is to vaporize the sample in order to make it into a gas. Yeah, and this gas particle is going to be hit by a electron gun, which is going to make it into a positive ion because it's going to knock out an electron from the outer electron shells. Next, there's a negative plate there. This negative plate, because it's negative and the ion is positive, is going to be attracting it, so that's going to accelerate the positive ion and make it into a beam. This is going to go towards a magnetic field. Now this magnetic field is going to deflect the positive ion, but key thing here is the smaller the mass to charge ratio of it, that means it's going to be a smaller ion, and a smaller ion will deflect more, and the highest deflection angle possible is 90 degrees. So that's another key thing to remember. Next, we go down here, it goes towards the detector. Now the detector has lots of electrons, and these electrons, as the positive ions coming through, is going to be attracted to the electrons, and as the electrons are being attracted, it's going to create a current, because it's going to be a movement of electrons. This current is going to be registered by the detector, and if there's a higher abundance of it, then it's going to create a more higher current, and that's how you know there's a higher abundance in it. Next, we're going to talk about interpreting the graph. If it's just a percentage abundance, you just do 24, which is the mass to charge ratio, times the percentage. And you do it for all of them and divide it by 100. Why? Because the percentage abundance all add up to 100. But there are situations where the abundance does not add up to 100. For example, here. Now, to identify this element, we've got mass to charge ratio, but we've got relative abundance and not percentage abundance. So naturally what we're going to do is 90 times 9, which is the relative abundance. Do it for all of these, and this time we're going to divide it by the total abundance, which in this case would be 9 plus 2 plus 3 plus 3. So that will give you a total of 17, and you'll be able to get the actual ion.